Hello students, in this lecture we are going to discuss question number 12, 13 and 17 from exercise 5.7 of class 12 mathematics. So let us start with question number 12. The question is, if y equals to cos inverse x, then find d2y by dx square in terms of y alone. In terms of y alone. It means when we find the second order derivative of this given function, then on the right hand side we have the function which contains y alone. So the solution is like this: y equals to cos inverse x. This is the given function. We have to find the second order derivative of this given function. So let us start with the first order derivative. So first of all we will find the first order derivative of the given function. So differentiating this given function with respect to x on both sides. So we will write this as dy by dx on right hand side, dy dx of cos inverse x. Now the differentiation of cos inverse x is minus 1 upon root 1 minus x square. Now since we want the result in the form of y alone on the right hand side, so we will put the value of x. So from here, y equals to cos inverse x. So what is x? X is cos y. So when we put the value of x here, then we will get this dy by dx equals to minus 1 upon the square root 1 minus cos square y minus 1 upon, and 1 minus cos square y is sin square y. So this is sin square y. So square and square root cancel out, minus 1 upon sin y, or we can say minus cosec y. So this is the value of dy by dx. Now further we differentiate this both sides with respect to x. So d2y by dx square equals to, when we differentiate this, this is minus d by dx of cosec y. Now as we know that the differentiation of cosec x is minus cosec x cot x. So for time being, let us suppose that this y is x. So the differentiation of this is minus cosec y and cot y, and this minus is as it is. But this is not x. So we will write the derivative of this y in the product, means dy by dx. And the value of dy by dx is what? Minus cosec y. So this minus and minus become plus. So we have cosec y, cot y, and the value of this is minus cosec y. So finally d2y by dx square is, when we multiply all these three, then this is minus cosec square y cot y. Now come to question number 13. Question number 13 is, if y equals to 3 cos log x plus 4 sin log x, then show that x square y2 plus xy1 plus y equals to 0. So this function y is given and we have to prove that x square y2. y2 means second order derivative plus x y1. y1 means first order derivative plus y equals to 0. So we will start with y equals to 3 cos log x plus 4 sin log x. Now first of all find the first order derivative. So we will differentiate the given function with respect to x on both the sides. So this dy by dx, it can also be written as y1. And on the right hand side, these two are the functions having plus sign. So separately we will find the derivatives. That is 3 cos log x plus d by dx of 4 sin log x. Now this 3 is constant, so the derivative of cos x is minus sin log x. But since this is not x, so we will write the derivative of this log x in the product plus this is 4 is constant and we will treat again this log x as x. So the derivative of sin x is cos log x, but this is not x, so we will write the derivative of this log x in the product. So this is like this. Now this is minus 3 sin log x and derivative of log x is 1 by x. This is 4 cos log x and derivative of log x is 1 by x. This is y1. Now on the right hand side we have x in the denominator. So multiply the whole equation by x. So here this is x y1 x, this is minus 3 sin log x 1 by x, this is 4 cos log x 1 by x. So when we multiply the right hand side by x, then these x cancelled. So we will get x y1 equals to minus 3 sin log x plus 4 cos log x. So look at the thing that we have to prove. In this x should be in the multiplication with y1. That's why here we just multiply both the sides by x, so that these x will cancel out and on the left hand side we will have x y1. Now again differentiating both sides with respect to x. So on the left hand side we will use product rule, means d by dx of x y1 and d by dx of minus 3 sin log x plus 4 cos log x. So on the left hand side we will use product rule. First function as it is, derivative of y1 is y2. Now y1 as it is and derivative of x is what? 1. On the right hand side again this minus 3 is constant and dy dx of sin log x 4 is constant, dy dx of cos log x. Now this is x y2 y1 minus 3 is constant Now derivative of this sine log x. So we will treat this log x as x. So the derivative of sine x is cos log x, but this is not x. So we will write the derivative of this log x in the product. Now this 4 is constant. The derivative of cos log x. So we will treat this log x as x. So the derivative of cos x is minus sine log x, but this is not x. So we will write the derivative of this log x in the product. Now this is minus 3. It is cos log x, and derivative of log x is 1 by x. This is minus 4 sine log x, and derivative of log x is 1 by x. This is x y2 plus y1. Now again we have x in the denominator, so multiply the left hand side and right hand side by x. So this is x y2 plus y1, and when we multiply the right hand side by x, then these two x are cancelled. Then we have minus 3 cos log x minus 4 sine log x. Now in the next step, this x and x becomes x square y2, and this is x y1. When we take minus common, then we have 3 cos log x plus 4 sine log x, and this is nothing but the value of y. So we can say that this is minus y. So x square y2 plus x y1. When we transfer this minus y on the left hand side, then plus y equals to 0. In this way, the result is proved. Now come to question number 17. In this we have, if y equals to tan inverse x whole square, then show that x square plus 1 whole square y2 plus 2x x square plus 1 y1 equals to 2. So this we have to prove. So this question is same as question number 13. So we will use the same method. So the solution is like this. Y is tan inverse x whole square. So differentiating both sides with respect to x, then we will get this is y1, and on right hand side we will write d by dx of tan inverse x whole square. So we will treat this as x. So the differentiation of x square is 2x, means 2 tan inverse x. But this is not x. So we will write the derivative of tan inverse x in the product. Now this is y1. On right hand side this is 2 tan inverse x, and the derivative of tan inverse x is 1 upon 1 plus x square. So when we cross multiply, or you can say multiplying both sides by 1 plus x square, then we will get 1 plus x square y1 equals to 2 tan inverse x. Now again differentiating both sides with respect to x. Then we have d by dx 1 plus x square y1 on the left hand side, and d by dx of 2 tan inverse x on the right hand side. Now on the left hand side, these two are the functions which are in product. So by using product rule, this first function as it is, now d by dx of y1, then y1 as it is, d by dx of 1 plus x square. On right hand side 2 is constant, d by dx of tan inverse x. So this becomes 1 plus x square. Derivative of y1 is y2. Now y1 is as it is. Derivative of 1 is 0 and the derivative of x square is 2x. On the right hand side this is 2 and the differentiation of tan inverse x is 1 upon 1 plus x square. Now again multiplying both sides by 1 plus x square. So on the right hand side this 1 plus x square cancel out and here we have 1 plus x square whole square y2. Here this is 2x and 1 plus x square y1 equals to 2. So this is the result that we have to prove. So in this way we can prove the results. The main thing is that after first derivative just change the function according to the result that we have to prove. यहाँ हमको product में x square plus 1 लाना था. That's why in this step we will multiplying both sides by 1 plus x square so that we have 1 plus x square into y1 on left side and a number without denominator on the right hand side. And again by differentiating the function both sides we will get the desired result.